This one says solve the system. And notice, just like on the front, I have a couple different questions that say solve the system. Okay, remember what we have to do is be really observant of what we're given. In this case, I have two equations that start with y equals. Now remember, this y and this y are equal. So if this y equals 5x plus 10, and this y equals negative 4x minus 17, that means all four of these things that I have circled must be equal, right? Because these two y's are the same. So if this is equal to this y and this is equal to that same y, these two expressions must be equal to each other. So I'm going to write 5x plus 10 equals negative 4x minus 17. And then I'm ready to just go ahead and solve this equation. I have x's on both sides, so the first thing I'm going to do is knock the x's off one side. For me, I like to knock, if there's negative x's, I like to get rid of those, right? Make my life a little easier. I'm going to subtract 10 from both sides. I'm trying to get x by itself now. Okay, again, feel free to use your calculator throughout to avoid silly mistakes. I get x equals negative 3. Now, as always with a system, I am not done because remember my answer is always going to be x comma y. So here I have two equations, and what I'm going to do is actually, I'm just going to plug this x back into both equations. You could absolutely plug it into one and then check it in the other, but I find that with equations in this format, it's just so quick to plug in. It's almost faster to just do it like this. So here I get 5 times negative 3 is negative 15 plus 10. That's negative 5, so that's y equals negative 5. Over here, negative times negative is positive. 12 minus 17, that's also y equals negative 5. And basically, I just checked my answer because I got the same thing in both equations. So there it is. Okay. Now in this next question, look, I want you to see this is an easier question. It's not asking me to find the solution to the system. It's just asking if this is it. Now, could I solve the system and see if I get this? I could, but that seems like a lot of work compared to what I could actually do, which is just say, oh, this is x and this is y. Let's see, does that work? Let's plug in. Y is negative 7. Look, I'm writing this equation. Y equals 5x minus 13. Look, y equals 5x minus 13. I'm going to do the math, right? There's no math to do on the left. Let's just do this. 5 times 2 is 10 minus 13. I get negative 7 equals negative 3. That is actually not true. This is not a true equation, and therefore the answer is no. Now, it might fit in this equation. I could check, but I don't need to because in order for it to be a solution to the system, it has to be a solution to both equations. So even if it were to work in this equation, the fact that it doesn't work in the top equation, I'm done. It's not a solution to the system. Solve the system. Okay, this one, I notice it's a similar format to this, which is I have two equations in standard form. Okay, so I am going to use elimination, but here's what I don't have. See how here I had a 4y and a negative 4y? Here I do not have that. So what I'm going to have to do is multiply in order to create that situation for myself. You can just choose. You can choose to multiply and get the x's to cancel. You can choose to multiply and get the y's to cancel. It doesn't matter what you choose. You just have to choose one. So, and remember, my goal is to have, like, for example, 6x and negative 6x sitting on top of each other like that. Or something like negative 9y and positive 9y sitting on top of each other. That is where this equals 0 when I add it, and that's what's going to get that elimination. So in this case, I could choose the x's because I notice, oh, they're already different signs. So that means I wouldn't have to mess with the signs. That's kind of nice. Or I could choose the y's because I notice, those numbers are smaller. Okay. If I were to choose, look, I'm going to choose the x's just, oh no, because I have to choose one. If I were to choose the y, I would say, 2 times 3 is 6. I would multiply the top by negative 3 to make it negative 6, and the bottom by 2 to make it positive 6. Okay, but I have to just choose one. I'm going to choose the other one. I'm going to choose the x's. I notice one's already negative and one's already positive. 3 times 5 is 15. My goal is to make this negative 15 and to make this positive 15. So negative 3 times what is negative 15? Times 5. Okay, I'm going to multiply this whole equation by 5. That's going to make this negative 15. Then I'm going to multiply this whole bottom equation by 3. Why? Because then this will equal positive 15. Okay, so look, I'm going to multiply, and I'm just going to write what I get right underneath here. Okay, I'm going to put it right here. 5 times negative 3 is negative 15x. 5 times 2 is 10y. And 5 times negative 12 is negative 60. Now here, 3 times 5x, that's 15x. 3 times 3y, that's 9y. And 3 times 20 is 60. So when I go, this eliminates, which is perfect. That's exactly what I want. 10y plus 9y is 19y. And negative 60 plus 60, it just so happens this equals 0 as well. I'm going to solve for y. 0 divided by 19 is just 0. But again, I am not done because remember, my systems are always x comma y. Careful, in this case, this is a y value, so keep track of your letters, right? Don't get mixed up and think this is an x. This is y equals 0. Let's go back into one of the equations. I'm just going to grab this bottom one and plug in 0 for y. 3 times 0 is 0, so I have 5x equals 20. I'm going to divide by 5 on both sides. I get x equals 4. And then let's just go ahead and check it in the other equation. I'm going to grab that top equation, negative 3x plus 2y equals negative 12. This becomes x is 4, y is 0. This becomes negative 12 plus 0 equals negative 12, and that's true. Let's keep moving. Here I'm given two functions, a g and an f. These are both just equations that I can plug into. This says get the g equation and plug in a 2 for the x. So I'm going to take the g equation, look, I'm going to copy it. 7 times x minus 3. So I just copied, and the only thing I did was instead of x, I put it in a set of parentheses so I can plug in. And what am I plugging in? This 2. 7 times 2 is 14, minus 3 is 11. This says get the f equation and plug in a negative 5. Here's the f equation, negative 5x plus 4. I'm plugging in negative 5. Negative times negative is positive. Okay, here when there's 2, this says, hey, you're going to plug into the g equation. Well, what am I going to plug in? Well, I'm going to plug in this. Well, how do I know what this number is? Well, this number is, take the f equation, plug in negative 1. So we have to do the inside first. Okay, so first I'm going to get the f equation and plug in negative 1. And then what I get, that's what I'm going to plug into the g equation. Okay, so f of negative 1, I'm going to go get the f equation, which is negative 5x plus 4. I'm going to plug in negative 1. Negative times negative is positive. This is 9. So now I'm going to plug in 9 into the g equation. That's 7 times x minus 3, plugging in 9. And I get, I get 60. Okay. Over here, graph the system. This is, I notice there's no x here. Okay, where's the x? It's being multiplied by 0. Okay, so this is this. So I'm going to go, this is still y equals mx plus b. Okay, both of these equations are, look, here I do have an x, but I'm missing my y-intercept. This is this. Okay, but both of these are equations in the same format, y equals mx plus b. Let's start with this one. I'm going to start at a y-intercept of negative 4. My slope is 0. That's the same as 0 over 1. I'm going to rise 0. That means don't move. And run 1. Okay, this is a horizontal line. This one has a y-intercept of 0. And this time, I have a slope of 2. 2 over 1. I'm going to rise 2, run 1. Okay, my line looks like this. My solution is right here. Let's see what that point is. It's always x, then y. Always x, comma y. So here, my x value is negative 2. And my y value is 4. Down to my last couple problems. Miss Broderick has 40 cookies. Each day she eats 5. Write an equation in slope-intercept form. It's telling me right off the bat that I'm using slope-intercept form. Remember, I need a starting point, my y-intercept, and a change. My starting point is I have 40 cookies. And now, am I gaining 5 cookies or losing 5 cookies each day? I'm losing 5 cookies. I have a negative rate of change. Here, this is just like solving an equation, only it's an inequality. So the only difference with an inequality is that if I multiply or divide by a negative number at any point, I have to switch the sign around. So right here, when I'm dividing by negative 4, this sign, which was mouth open towards the x, is now going to flip around and have the mouth open towards the other side. Nothing else changes. This is 24 divided by negative 4. That's negative 6. Okay. This says x is less than negative 6. So when I'm graphing, I ask myself, open or closed circle. Okay, in this case, this says less than, not less than or equal to. That's an open circle. And do I shade left or right? In this case, this is a less than sign. I want to shade the numbers that are less than -6. You can also kind of use this as a hint. It's the arrow that's pointing the same way. Okay, in this case, there's just not much space to shade, but I'm going to shade this way. Okay, shading the other way would look like me shading this whole line and shading the other way. Okay, last question. For each of these, this is two lines shown in each graph. I want to know which one has no solutions, which one has one solution, and which one has infinite solutions. A reminder that the solution is where the two lines meet. So here, where they meet one time, that's one solution. Here, where they don't meet at all, they never will, they'll go on forever and not meet, this is no solutions. And here, there's two lines sitting on top of each other. Look, here's one line, and look, here's the other. Where do they meet? Well, they meet here, and here, and here, and here, and here, and here. Forever and ever and ever, they just keep meeting. Okay, this is an infinite number of solutions. They meet everywhere.